In this part 2 video or update video, I thought I'd talk about what worked and what didn't work. It's almost been 2 years now and about 3,000 miles, and let's get started. Cosmetically, the only thing I've done to the bike is on the side panels of the battery box, I added some carbon fiber vinyl tape, and that was basically just to take away some of the shine of that aluminum. Two other changes I made to the bike was I changed out the front headlight, opted for this dual multi-LED light, which is quite a bit brighter than my my last setup. And you can see, well, blows out the camera, but it throws out some pretty good light. I'll show you from the sides here. It might look like the cable's in the way, but it's really not. And then one of the other changes I made was added these strobes on top and the bottom. That way I got away from the rechargeable lights I had. And basically these were off of a motorcycle, found them on Banggood, along with the headlight, found it on Banggood. And included in that set was a set of rear strobes, again allowing me to get away from the rechargeable light in the back. One of the early additions to my bike is I added this LED display which shows voltage and current draw from my accessory battery. It's currently a 20 volt battery, and as you can see it's showing 19.1 volts, and then when it's blinking it's showing you the amperage draw. And so like right now idle it's 0.6 amps, and if I kick on the headlight you'll see it's 1.7 amps. So it allows me to see the status of the battery without having to take things apart. Also I added, in conjunction with this, is a DC to DC variable voltage regulator. So it allows me to adjust this 19 or 20 volts down to 12 volts, where I can use it to run all my accessories, the Wi-Fi, the strobes, the headlight, and everything like that. As you can see, my handlebars are getting a bit cluttered, but one of the new things I added was this tire pressure monitoring system. Allows me to see the pressure in the front and the rear tires, and even shows the tire temperature. And the way it works is just by mounting these sensors on the front and rear Schrader valves of the tire. It transmits a signal back to the head unit. It allows you to see the current pressure both front and rear. Just to the left of the tire monitoring system, I added this front-facing camera so that I can record video in front of me, and then with my rear-facing camera I can also record video. So it allows me to record front and rear, just in case something were to happen. Hidden behind the tire pressure monitor is a dual port USB accessory plug. And this is actually from Banggood as well, for a motorcycle. You can tell it has a mount for a handlebar. Dual port, so one is 1 amp and the other is for 2 amp. It even has its own power switch on the front side. And I use this, typically one plug is to keep my my front camera charged, and the other one I use, the higher amperage, I use for powering my glove warmers. One of the things that I learned early on is that when you connect your batteries to your motor's controller, it creates a huge spark. And basically what's going on there is that the instant load of charging the capacitors creates that spark. Well, that spark can damage the battery management system inside the DeWalt batteries. So by adding what I'm calling this spark switch, it's basically a momentary switch in series with a 150 ohm 5 watt resistor. It pre-charges the capacitors, eliminating that spark, and thus eliminating any damage to your batteries. I've drawn this simple schematic to show you what I'm talking about here. The plus side of the 60 volt batteries are connected in parallel and lead to the main battery disconnect and to the momentary spark switch. Typically, when connecting the batteries to the bike's controller, you'd want to have the main battery disconnect in the off position. At this point, you could press the momentary spark switch, which would allow current to flow through the switch, through the 150 ohm resistor, and into the controller, gradually charging the capacitors inside. You only need to hold the momentary switch down for about 5 to 7 seconds, At that point, release the button and you can turn on the main battery disconnect and you're on your way. In this display, you can see the problem with a bad battery management system. It displays incorrectly the cell's voltage. The cells inside this battery pack are within 1/10 of a volt of each other, but the BMS shows cell pack 2 low and cell pack 3 high. A balanced charger sees this imbalance and will not charge the battery. With a good BMS, you should see near equal voltage levels in all cell packs. A few months back, I upgraded to DeWalt's 12-amp FlexVolt batteries, giving me a 60-volt 20-amp system. The way I charge my batteries is using this SkyRC Ultimate Duo. And basically, it's 2 battery chargers in one. And the way I connect the batteries into the SkyRC is I've modified this Chinese knockoff of a DeWalt USB charger. And all I'm doing is using the pins from it to connect a line straight out and into the SkyRC's balance port. I also have the optional temperature probe for each channel so that I can monitor how the batteries are charging. I have yet to see these batteries overheat while they're charging. In my part 1 video, I talked about my electric park brakes. Here's a recap of that part of the video. So what I did was converted the front handbrake to an electric park brake. And I'll show you that in working. Did it also for the rear. So here's, as you can see, the motor cranks, squeezes the brakes together, locks them up. Same for the rear. It's a little different system, but it works the same. Locks up the bike. Well, I came up with a new use for my electric brakes. Along downhills, instead of riding my main brakes, I just add some drag on the electric brakes to slow myself down. At the bottom of the hill, I just release the drag and I'm on my way. By far my favorite new toy is this Garmin radar unit. Right now it's in test mode, and as you can see with that white progression, it's symbolizing a car that's approaching from behind you. It can track up to 8 different cars at about 250 feet behind you. So that's the head unit. And then to the rear of the bike, you mount the radar unit, which also has a flashing red LED. And the rate of flash changes with the cars that approach you to help get their attention. You may have noticed the black box attached to the side of my battery box. One of the negative things about the Garmin radar unit is its alert tones. There's no level adjustment. It's either on or off. It may sound loud now, but when you're actually out riding, it's hard to hear the alerts with all the background and road noises. Add headphones and music, and you can't hear anything from the radar unit. This box, which let me say right up front is a work in progress, helps me deal with the alert tones and not being able to hear them as I ride. Using my phone's headphone jack, I feed the left and right audio channels and the data line for controlling the music player into the box. From this point on, I'll be calling the box my radar amp. The sound and data pass through the radar amp and into the headphones plugged into the radar amp. If I should have to turn off my radar amp, I will still have sound and control of my player. A pickup is attached to the head unit of the Garmin radar and is fed into my radar amp. The audio from the radar's head unit is mixed into the left channel of my earphones. In this clip, you can see and hear what I hear as I'm riding. The system overall works pretty well on the street. The music drowns out what little road noise there is. When I go off-road, I just turn off the radar amp.